Determine the concentration in moles per liter of the following weak acids. This is video problem 88. Still working on the pH scale here. Just some more pH problems that you might see. So we're given a pH, and we're asked to find what's the concentration of this HA. Alright, so what does the pH tell us? Well, the pH can actually tell us the concentration of the hydrogen ion, right? But remember, this is a weak acid, so that means that the concentration of the hydrogen ion is not necessarily the concentration of the weak acid. Matter of fact, it's not. I guarantee you it's not. Right? But the concentration of the hydrogen ion and the concentration of A minus are the same. And if we look at our Ka expression, so let's get our Ka expression over here. That means I know this, and I know this. That means I can easily figure out what HA is, right? Because if I look at my ice table, let's go ahead and do an ice table here. H plus, A minus, HA. So my H plus and A minus start out with 0 amount. This is starting out with some amount Y. I don't know what it is. Okay? This is going to go up by some amount X, up by some amount X, down by some amount X. So it's going to be Y minus X, X, and X, but I know what the equilibrium concentration of the hydrogen ion is. Right? So let's go ahead and figure that out. 10 to the negative 1.25. And I get a hydrogen ion concentration of 0.0562, and that's my equilibrium concentration. So that's what X is. So I know what this number is. I didn't want green, I wanted red. I know that this is 0.0562. This is also 0.0562 because it's that same X. And then this is Y minus 0.0562. So I can easily plug all these in. Let's go ahead and do that. 0.0562 times 0.0562 all over Y minus 0.0562, where Y is the initial concentration of HA. So that's all equal to 2.45 times 10 to the negative fourth. So let's see, 0.0562 squared, I get 0.00316 is equal to 2.45 times 10 to the negative fourth Y minus that's a big small number, minus 1.377 times 10 to the negative fifth. So I'm going to add that value to both sides. So I get 0.003174 is equal to 2.45 times 10 to the negative fourth Y. So I'm going to divide both sides by that 2.45 times 10 to the negative fourth. So I get a value of 12.95. So that's the molarity of that acid. Okay? Same exact idea here. Why don't you go ahead and pause it, try to solve it, and then you can play it and see my solution. So I'm not going to talk that much here. Okay, so here we are. Hopefully you got at least this far. And then I can set up my Ka expression. See, that's HN3, hydrozoic acid, equilibrium. This is the azide polyatomic ion. So come over here. Plug it into my numbers. Alright, so what do we get? What's that times 1.9? So I get a value of 6.31 for this one. Okay, oh, this is HN3. So there you go. Hopefully you got the same thing. And just real quick, like a lot of times students will, we normally drop this x value, and a lot of times students will do that in this type of problem, but you know what x is. There's no sense dropping it. The only reason we drop it is because we usually say, oh, it's so small that it doesn't matter, but we know what that value is. Don't drop it if you know what it is.